Hello, this is Mr. Price, and this is the video on the year 9 for Unit 15, problem solving with Pythagoras. We're going to go straight into these because there's a few questions we need to do today. Okay, so for the first one, it's asking us to find the missing dimension on this right-angled triangle. Just going to do a quick sketch. It's 30 centimeters for the hypotenuse. This value here is x, and then we've got 24 centimeters there. Okay, so first thing I'm noticing is I'm calculating a shorter side. So that means using Pythagoras' theorem, the hypotenuse squared subtracts the other side squared, which I'm going to call a squared, is equal to the other side squared, which is squared, will give me the other value squared. Now putting that onto my calculator, 30 squared to take away 24 squared is 324. And this is still equal to x squared. So to find the value of x, I square root both sides. Just going to zoom out a little bit so we can see the whole question. So I square root this, and I get an answer of 18 centimeters for x. I'm going to put this onto my diagram and check my answer makes sense. So 18 plus 24 is bigger than 30. And the hypotenuse opposite the right angle is indeed the longest side. 30 is bigger than these two individually. So perfect. My answer looks sensible. I can tick this one. Okay, let's move on to question 2. I've got a triangle looking like this. And I've got a side here 24 centimeters, side here 32 centimeters, and x here. Okay. So this time I can spot I'm calculating a hypotenuse, okay, which is opposite the right angle. So I'm going to use, I know the two shorter sides, a squared plus b squared, will equal the hypotenuse c squared. So substituting in my values, I've got 32 squared for one shorter side, 24 squared for the other shorter side, and then x squared for the other side. Okay, substituting those into my calculator, I get 1,600 equals x squared, and then to get the x by itself I'm going to square root. So I square root this and I get the answer 40 centimeters. I'm going to put this onto my diagram and check my answer makes sense. So 32 plus 24 is bigger than 40. And the side opposite the side opposite the right angle is the hypotenuse. This should be the longest side, and it is. So we can almost tick this answer ourselves. It looks sensible. Okay, let's look at section 2. So I've been asked to correct the mistakes on here. So let's have a look at the first one. So the person's done their check and they've noticed 2 plus 7 is greater than 53, okay, for their answer here. So something's gone wrong. This number here is far too big. So chances are, if we look through here, they've missed off a square sign here and here. So that means when they get to this stage, it's 53 equals c squared. So then they've got to square root this. Okay, they've forgotten to square root both sides. So there's their mistake. And if we just calculate that final bit for them, they should have got an answer of 7.28 to one decimal place, which now looks much more sensible. Okay, let's look at B. So when they've done their checks, they've noticed that the hypotenuse is not in the correct place. They've worked out this to be 18.03, which is clearly larger than 15. So here's their mistake. When we see this, we should be thinking they've probably used the wrong Pythagoras' theorem up here, and they have. They've added the longest side and the shorter side, when what they should have done is taken away the shorter side from the longest side squared. So I'm going to correct that up here. So what they should have done is, if I just quickly sketch out this triangle again, okay, is 15 squared subtract 10 squared equals x squared. So when I put that into my calculator, I get 125 equals x squared. So then when we square root this, we get x to equal 11.2 to 1 decimal place centimeters. And that's the mistake. So, okay, let's look at section 3. These are worded questions. So, is a triangle with sides 7, 24 and 25 centimeters right angled? Give a reason for your answer. Okay, so we know that Pythagoras Theorem only works for right angled triangles. So if I sketch this triangle as if it was right angled, and make sure I put the hypotenuse in the right place. So 25 is the longest side, so I'm going to put that in the correct place. And then 7 and 24 in either order over here. Okay, let's use Pythagoras Theorem to see if 7 squared plus 24 squared is equal to 25 squared. So, 7 squared plus 24 squared should equal 25 squared. So, on my calculator, 7 squared plus 24 squared is 625 equals, and then 25 squared is 625. Okay, so this makes sense. If it wasn't right angled, we would have had some kind of silly thing like 625 equals something completely different. So clearly, yes, this is right angled. Yes, as Pythagoras' theorem, I'm going to shorthand here. So Pythagoras' theorem works for this triangle. And Pythagoras' theorem only works for right angled triangles. Something along those lines. You've got to be very specific when you give your reasons. Okay, question 2. I've got two coordinates here, A and B with 13, 6 and 1, 1. I want to work out how long the line is that joins them. So if I do a rough sketch of this, so if this point here is 1, 1, and then I go along 13 and up 6, this will be 13, 6. I've got this line here. Now, if I draw vertical and horizontal lines to make the point, I can see I get a right angle triangle. So I can work out the length of this line by using Pythagoras' theorem. So the length of this, so it starts at 1 and goes to 13. So that means its length is 12 units long. Okay, this one starts at 1 and goes up to 6. This is 5 units long. So now I can use Pythagoras' theorem to work out the hypotenuse. So I know 5 squared plus 12 squared, I'm going to label this side x equals x squared. Using my calculator, 5 squared plus 12 squared equals 169. Equals x squared. So now I square root this to get my value of x. And I get 13. Okay. As always, I check my answers sensible. So the longest side is indeed in the correct place. And 12 plus 5 is greater than 13. It's 13 units. There's no centimetres or metres for this one, it's just units. Because I wasn't given any units in the question. Question 3. I've got a rectangle here whose diagonal is 10 centimetres. And I want to know what the possible values for my length and width are. Okay. Now, this is a very tricky question, but it requires just a little bit of different thinking to what you may be used to. Okay. So, obviously, A and B can be an infinite number of values. Okay. If this is, say, 2, B will be something completely different. And these values can be anything as long as it works for this triangle. So, to start off with, I'm going to think of an extreme condition. Okay, and my extreme condition is that A is actually going to be 0. It's going to be nothing. Now, yes, I know this is possible, but it could be 0.0000001, and it would make an incredibly small triangle. So, I can assume it's just 0. I'm going to use Pythagoras Theorem for this. So, I know to work out b, I'm going to have 10 squared subtract a squared, which is 0 squared, will equal b squared. So 10 squared is 100. Take away nothing equals b squared. So clearly, when I square root this, I'm going to have b is equal to 10. Now the question was asking me, what are the possible values for the perimeter? So if this side's 10, this side's 10, this is 0 and this is 0, then the smallest possible perimeter is going to be a number just larger than 20. Because I've got 10, nothing, 10, nothing. So the perimeter, perimeter minimum is going to be 20 centimetres. Now on to look at perimeter maximum. Now it might be tempting to now make the other side 10 and the other side 0, but then I'll just get the same answer again. So I want to think what's going to be in the middle of this extreme, and that's going to be when it's actually a square. Okay, so when it's a square, that's its other extreme value. Otherwise, these values are going to negate each other out. Okay, so when it's a square with a diagonal 10, I want to work out these values here. Okay, and this is going to be an isosceles right angle. So using this condition, I've got 10 squared, take away a squared, will equal a squared. Okay, because the hypotenuse take away the shorter side will equal the other shorter side, and they're the same value. Okay, now to solve this, I want to get all the a's by themselves. So I'm going to add a squared to both sides, and I get 10 squared equals 2 lots of a squared. Okay, I then get 100 equals 2a squared. Divide by 2, I get 50 equals a squared. So when I square root this, square root of 50, I get about a equal to 7.07. So now for the perimeter, each side is 7.07, so I'm going to multiply that by 4, and my largest possible perimeter is going to be 28.28 centimetres to 2 decimal places. Okay, now that was a very strange, unusual question. Well done if you did follow what was going on there. Now, you're not really meant to remember exactly what I did there, but what you do need to remember are the stages I did. So think of extreme values and use those values to get some answers there. So one extreme 0 and the other extreme is perfectly in the middle. Okay, and finally the last question is involving a pyramid with a square base area of 400 centimetres. Now, I'm not the best at drawing here, but I'll try my best. Okay, so here's my very rough pyramid. I know it's not brilliant. Okay, and the area of that base is 400 centimetres squared. So the first thing I'm going to do is I'm just going to work out the square root of this to work out what each length is. So the square root of 400 is 20. So each side is 20 centimetres. Now, I want to know the height of this pyramid, and I know these side lengths are worth 25 centimetres from the question. Okay, so first I'm going to look at this triangle here. If I use a different colour pen, it might be easier for you to see. So first I want to get this length here. Okay, so I'm going to work out that right angle triangle. So bringing this out here. Okay, I don't know this value. I know the side length is 25 centimetres here, and I know this bit is half of the 20 centimetres, so that's going to be 10 centimetres. Okay, so using Pythagoras Theorem, 25 squared take away 10 squared equals x. By now we should be used to using Pythagoras Theorem, so I'm going to skip to the final answer. So 25 squared take away 10 squared is equal to 5 root 21. I'm not going to round it here. I'm going to leave it like this. Okay. So now I know this bit. So therefore I also know that bit and this bit and that bit. So now, if to get the height, there's another right angled triangle in there. I realise it is quite difficult to see. So there's another right angled triangle here. Okay, so bringing this one out. I know the diagonal here was the answer to this part here. So that's now going to be 5 root 21. I know this bit is still half of the length, so that's still 20. And now I want to know the height. Whoops, sorry. Okay, so let's now finish this off using Pythagoras Theorem. So, 5 root 21 all squared. Take away 20 squared will equal x. So 5 root 21 all squared. Okay, so I want to keep my answer exact, is 525, back to where it started over there. Minus 20 squared is 400, equals x squared. So getting my final answer in here, x is equal to 5 root 5, which is about 11.2 centimetres for the height. Okay, that was a very challenging question. It's not easy to show on the whiteboard, but always come and see me if you want to check in more detail how to do this. This is an A-star question using the old GCSE grading system, so it's not an easy question at all. Really good job if you tried it and followed the video to some extent. Thank you very much.